So now we will look at the practical applications of trigonometry, that is heights and distances. First we will learn a few technical terms and then we'll move right on to the examples, because there isn't much theory in this. We have to continuously do problems, solve questions to understand better. Okay. Now in real life, what happens, how do you make a right angle triangle? How do you justify making one? Suppose there's a tower, alright? This is a tower, a telephone tower. Suppose there is something, and this is the midpoint, this is the ground level. Okay, so suppose you want to find the height of the tower. Now it is actually very impractical to just go up and try to find height by conventional methods. So what do? You go at a specific distance away, say x meter. You are standing here, then you look at the top of the tower, you find this angle. When you find this angle and you know this distance, then you can easily find the height of the tower using trigonometric ratios. Alright, so in this case, this angle, suppose we call it angle theta. Theta is a Greek letter, and it is very commonly used to express angles. Okay, so this theta, in this case we call it the angle of elevation. This bottom line from where the observer stands, this is the horizontal level. This line, this is the observer's line of sight. Now also, suppose if this weren't a tower, if this were a balloon or suppose a kite floating in the sky, this would have been an object. So we call the top of this triangle as the object. Alright. Now what if it was inverted? Like suppose you are standing at the top of a building. This is a building, you are standing at the roof. There's something down here. Suppose a river is flowing. Okay, your building is just by the riverside and you are staring at the opposite bank, and you want to know the distance between your building or this bank and the opposite bank. So you look down, you know the height of the building, you know this angle, and then you can easily find this distance. And if you know this distance, you can calculate the width of the river. In this case, this theta, this will be called the angle of depression. Okay, when the line of sight goes above, it is angle of elevation. The other terminologies are the same. This is the object, this line is the horizontal line, this is the line of sight. The only thing changes is the angle. Here it is called angle of elevation, here it is called angle of depletion. Okay, so with that understanding, let us do a few questions. Now the first question, we assume here is a tower. Okay, suppose this line is a tower, this is the horizontal level. This tower stands vertical, and from the base of the tower, angle of elevation of the top, we are given, this angle is given as 60 degree. Okay, this distance, the distance between the foot and the observer, this is given as 15 meters. We have to find the height of the tower, h. Okay, so we can directly find this using tan 60 degree. Tan of this angle will be this side divided by this side, that is h by 15. Okay, tan 60 degree equals to h by 15. You can of course do it by other trigonometric ratios, but it will require finding out the hypotenuse, and that will be a long strenuous process. It's better to do it using just this. We know tan 60 degree, as we have already done, is root 3 h by 15 implies h equals to 15 root 3 meter. Now in the tests that you're normally going to get, assignments, homeworks, and all the rest of those things, they'll probably give the value of root 3 and you have to substitute and calculate the value and then give the answer. But for now, this much is sufficient. Okay, let's do more questions. We are given that here is an electrical tower. Here is an electrician. The tower is 5 meters long, but the fault is 1.3 meter below the top. Here is a fault and the electrician has to repair it. Alright, we have to find the length of the ladder required for the electrician to reach that point if we are given that the inclination here is 60 degree. Okay, so how do we proceed? Similarly as the last problem, we see that we actually need this height, so these two are as such redundant. We only need this to calculate this. We see 5 minus 1.3 is 3.7. we need to find this distance. No, actually, sorry, we need to find the length of the ladder x. The length of the ladder then can easily be found by sine 60 degree equals to 3.7 by x, and we also know sine 60 degree is equal to root 3 by 2. Alright, so this means x equals to 3.7 into 2 divided by root 3 meters. You normally would have to solve this and give the answer in terms of a definite number, but for now we just need to understand the concept, how it's done. So I think this is good. Let's do some more. We now are given, it's a slightly different kind of, it's a tricky question. We are given that there is an observer, this guy is a person, we are given the height of the person, and we are given that he is staring at a chimney which is 28.5 meters away from him. The height of the person is 1.5 meter. Alright, angle of elevation of the top of the chimney. See, now this is tricky because we don't want the angle to be taken from his foot, we need it to be taken from his head. Since this is a person, that's where his eyes will be. Alright, so this is now not the horizontal level. There's an imaginary line here that becomes the horizontal level. Alright, this angle is given to be 60 degree, and we have to find this length h. Okay, now what we can do with this triangle, we can find out this length. Say this much is x. Okay, we know this angle, we know this length, we can find out x. How? Tan 60 degree equals to x by 28.5. we also know tan 60 degree equals to root 3. So x is 28.5 into root 3 meter. Now things you can forget about this problem. First of all, like I told you, you might mistake it from his foot and that will give you a totally wrong answer. When you have done this and you find out x, do not forget to add this height, because this 1.5 meter also adds to the x to get the full height of the chimney, that is h. We have h equals to x plus 1.5 meter. This was tricky in that way because it needed a little bit of understanding as to why the man's height was given. I hope you can tackle these sort of questions now. Let's move on. Now, we are given that this horizontal level, angle of elevation of the top of a 10 meter tall building. Suppose here is the building. Meter tall building is 30 degree. Alright, and there is a flag hoisted at this building. Alright, and we are given also the angle of elevation of the flag. So this bigger angle becomes 45 degree. Okay, we have to find the height of the flag. Alright, now how do we proceed? See, in this sort of problem, we take into account what's given to us and proceed from there. First, we have the smaller angle 30 degree and the height of the building 10 meters. So we can find out the base length. So how do we do that? We know tan 30 degree equals to 10 by x. Let's say this is x meter, implies tan 30 degree is 1 by root 3 equals to 10 by x, implies x equals to what is x equals? 10 root 3 meters. Now when we know x and we know this is 45 degree, we can find out this whole h plus 10. Okay, so we get h plus 10 equals to, since this angle is 45 degree, tan 45 degree is 1, or also we can use the triangle properties that this length will be equal to this length. So h plus 10 equal to x, and x is 10 root 3, implies the height of the flag will be 10 root 3 minus 10 meter. Alright, you are probably required to solve for this, take the value of root 3 and substitute and then give the answer, but as long as the concept is clear, we're good. Stop. Start. We're going to do some more examples on heights and distances. Okay, here we go. We are given that there's a tower and the sun is shining on it at different times of the day. Alright, this is the horizontal level. We are given that at a particular time of the day, the shadow of the tower makes an angle 30 degree, but at this different time of the day, it makes an angle 60 degree. Okay, we have to find the height of the tower, given that this distance is 40 meters. It is worded in a very different way. It is said that the shadow at a particular time of day casts an angle 30 degree and the shadow at a later time of day casts an angle 60 degree, but it is 40 meter away from the shadow casted by the previous time of day, and we have to find this h. Okay. How do we proceed? We have to find the height of the tower. We are given these two angles and this distance. How do we proceed? First of all, let's say this is x. Now we have two unknowns, so we will need two equations to solve them. And where will we get those two equations from? We will take tan of both these. Okay. Now tan 30 degree. Tan 30 degree will be what? This by this, h by x. Okay. And from the bigger triangle we get tan 60 degree, h by this will be x plus 40, because we are considering the bigger triangle, x plus 40. We substitute the values. This is equals to 1 by root 3, this is equals to root 3. We solve for h and x. We get if you solve, you will get the answer. The wording of the problem and the understanding of the concepts is what important here. So this is how we will solve for x and h. We can get x as well as h, but we don't need x, so we can directly get the height of the tower from this, using this approach. Okay. Another problems, a few more problems. We are given 8 meter tall building. All right. Here's the building. This is 8 meter tall. Okay. And on the other side, we have a very tall multi-storied building whose height is as such unknown. They are both on the same horizontal level. Okay. Now we are given that the angle of depression. Why is it called an angle of depression? Because the person standing here has to look down, and using this reference line, this is theta, and this whole angle will be, say, this is suppose theta 1, this is theta 2. So since it is the line of sight is going down, we called it the angle of depression. We are given that these two angles are 30 degree and 45 degree. Okay. So we have to find the height of the multi-story building and the distance between the two buildings. Now how do we proceed using in this problem? First of all, we see that this angle is 30 degree, this is 45 degree. Okay. So 45 degree means this angle will also be 45 degree. So whatever the distance between these two buildings is, it's also the height of the building. That is currently not necessary, but it's a good observation and it's good to keep in mind. Then we start with the problem. We are given here 8 meter. So let's suppose this is the triangle, and this again is h as for the height of the building and also the distance between them. Let's say this much distance is y. Alright. Now we know that since this is 45 degree, this will equal that, and since that is 30, so let's call this h only. Let's not make another variable, and let's continue with the problem. So what do we see? Tan 30 degree. tan 30 degree. What will tan 30 degree equals? Y by this length, y by h, this is equals to 1 by root 3, and tan 45 degree will be equals to h by h, this will be 1. Thing is, we already know h equals to y plus 8. Okay, now from here we deduce that h equals to y root 3. So we substitute for y is equals to h by root 3 plus 8 implies h 1 minus 1 by root 3 equals 8, implies h equals to 8 root 3 divided by root 3 minus 1. Okay, you see how we tackled the problem. We were given only this 8 meter and the angles of depression on the top of the building and the bottom of the building at 30 degree and 45 degree. Now what we did, we since it was 45 degree, we just noted that this length between the distance between the two buildings will be equal to the height of the multi-story building. And then we assume that the distance between this 8 meter building and the multi-story building is a variable. We assign that variable, and then we know that this total distance will be the height of the multi-story building h. So we have one equation, h equal to y plus 8. Another equation we get from the tan 30 degree, that is since this distance is h, we get y tan 30 degree equal to y by h, this is equal to 1 by root 3. Then we substitute the value of y in the equation h equal to y plus 8, and we get h for both height of the multi-story building and the distance between the two buildings. Alright, let's move on. Let's do a last example on heights and distances, and then we'll move on to some advanced stuff that will help you prepare better for the JEE and all that. We are given, here's a river that flows. Suppose this is a river. We are given a bridge on this. Okay, this is a bridge over the river. From a point on the bridge, we are given that 30 degree and 45 degree. The angles of depression from point of the bridge are 30 and 45 degree respectively, and this bridge is 3 meter above the ground. Okay, we have to find the width of the river. Now how do we do that? It's very simple. We take this as 3 meter and this also as 3 meter. Since it is the angle of depression, the elevated distance will be the same. Then we just solve for x and y basically. Now since this is 45 degree, tan 45 is 1, so this 3, y will equals 3 meter, and tan 30 degree is 1 by root 3. So 3 by root 3 equals to x, this is equals to root 3 meter. So the distance of the width of the river, this will equal to x plus y equals to 3 plus root 3 meter. These type of questions seem pretty easy, but even if you get a little bit confused, the whole question could go off and you could get wrong answers. So it is important that you understand these concepts and you practice a lot of the questions so that you get familiar with them. Next, we'll move on to some of the advanced topics in trigonometry.